We're going to try to find values for h that will make it so that this quadratic formula has exactly two real solutions. If you think about the way we've been solving quadratics, we've been using this quadratic formula, and way back in section 2.2b, we talked about how the sign of the number under the square root symbol determines if it has no real solutions or two real solutions or one real solution. These notes are actually stolen from section 2.2b, but I wrote it like more mathematically. If you look back at 2.2b, this same phrase is written, but instead of here, it says b squared minus 4ac is negative. This is mathematically how you say something's negative. You say it's less than 0. This says the discriminant is positive, because if it's more than 0, it's positive. For this problem, since I'm trying to find two real solutions, I want to make sure that this expression, b squared minus 4ac, is a positive number, so it's more than 0. So the first part is just to figure out, given this quadratic with this unknown inside of it, what is the value of b squared minus 4ac? So just like before, a, b, and c haven't changed. The number in front of x squared is a, so a would equal 9. The number that's just in front of x would be b. So b is negative 5. This is where things get a little bit different. C is this entire thing, because we're going to find a value for h. So c equals 3 and h together. With this stuff in mind, I'm going to go ahead and figure out what b squared minus 4ac is. And because I want two real solutions, I'm going to have to reach back to my Algebra 1 skills and remember how to solve inequalities. So let's do this. B squared, I'll do that in my head. B squared is 25. And I'll have to do negative 4 times a, which is 9, and times c, which is 3 times whatever h is. That all has to be more than 0. What I like to do in math when I see something like this is focus on the ugliest part first. This is all pretty gross, so I might need to get a calculator out, but to simplify this, this is all one huge multiplication. I would do negative 4 times 9 times 3h. So with a calculator, I could figure out that, let's see, come on, turn on, you can do it. Negative 4 times 9 times 3 is negative 100, and then I'll just slap the h on there. So this 25 comes straight down. This is a negative 100h, and I'm going to make that bigger than or equal to 0. So now I get to solve for h. If you think back to Algebra 1, solving an inequality is almost just like solving an equation. We're going to do PEMDAS in reverse, and we're going to do all the steps we can to get that h all by itself. So as I look at this, I see that the h is being multiplied by negative 100, and this 25 is kind of like added on. So when I start PEMDAS in reverse, if there's anything to add or subtract, absolutely. I'll subtract 25 from both sides. These will cancel off. On the left side, I have negative 100 times h, and the right side is bigger than negative 25. So now I move up the ladder, and I say, what else is hanging out with h? Is there anything to multiply or divide? I'm going to divide. Here's where solving inequalities gets a little bit different. When you divide by a negative number, then what happens is this inequality symbol has to change directions. So my next line would be this side, these would cancel, would just be h. Because what I divided by was negative, this has to flip from greater than to less than. And then here's something where you could write it as a decimal or a fraction. I don't really care. I like fractions, so I would do negative 25 divided by negative 100, press my math button, press enter twice, and get that equals 1/4. So the final answer for this question is this. As long as h is less than 1/4, this quadratic would have two real solutions. That's it. It's a lot of work, a lot of review from Algebra 1. Some new ways of dealing with the functions, but it all comes down to remembering that the discriminant has to be either positive, negative, or 0 based on how many solutions you want to have. This is going to be a real noodle scratcher. Real noodle scratcher. So, good luck moving forward. I know you can do it. Persevere. Be awesome at it. Be patient.